Hello, and welcome to my video detailing my implementation and protocol design for Assignment 2, Part 1 for computer networking. To start off, I want to clarify that this video will detail my implementation of the application, service layer, and the basic functionality of the router. However, I need to clarify that the communication and the address forwarding between the two endpoint devices in the router are hard-coded, and they are currently only equipped to deal with two specifically named devices. However, this is enough for me to demonstrate a simple messaging application running in a service layer on each endpoint device, and the two are capable of sending and receiving simple text messages to each other. To start off, I'm going to launch my router device. This is the core for the purposes of this demonstration, as both endpoint devices require a connection to the router in order to forward packets. So now I'm going to launch my router, but we won't see anything interesting happen. Now that our router is launched, we're free to launch up our two endpoint devices, with the corresponding names for Alice and Bob, our demonstration clients. Upon launching our client, we're prompted to enter a name, and again, for demonstration purposes, this will be Alice and Bob. During the process of launching our endpoints, we can see that they sent a new packet type containing their name and device type, which is endpoint, to the router, which it then stores in its own forwarding tables. We can see one corresponding for both Alice and Bob, with their IP and port. This will be important later once we get around to sending messages. There are a few basic commands available in this command line interface, but for today, we'll be interested in send and ls. To send a message, all we do is type send hello. And we'll see in a second that this gets sent to our router device, and we can even see the TLV encoding that it has gone through before being sent. This is then forwarded on to Bob. Let's say Bob is just a normal user going about using other commands on his system, such as the help command. We now see that the prompt has updated to be a little letter. This indicates that an unread message has been received. We can read this message by running the ls command. And we see a message from Alice saying hello. Let's reply. This was sent, and we can see the router has received it, and this has now been forwarded on to Alice. We can read the message as Alice, again with ls. We see a new message from Bob saying, "How are you?" including the timestamp. You might notice that there's a -a argument listed next to ls in the help command. However, this is not currently implemented. In future, I intend to log all received messages in a text file for each device, allowing you to recall previously read messages without having them being stored actively in memory. Let's pop over to Wireshark and see if we can see these messages. Here we see in Wireshark a number of UDP packets sent between our devices. When we select these, we see endpoint, Alice. That's our new type device when Alice was instantiated. Here we see our hello message sent by Alice. This was it being forwarded from the router back to Bob. And now we see how are you being sent by Bob to the router, and that message being forwarded on to Alice by the router. I'm pretty satisfied with this implementation overall, and it's programmed in such a way that I should be able to readily expand this to have more complicated forwarding and the ability to handle multiple endpoints and addressing various ones by name during the send command. As always, my code is available on Github, which will be linked in both the submission and the description for this video if you're watching on YouTube. Thank you so much for watching, and I hope you have a great night.